But I'll make it. Sorry, just been a late day today. So let's go straight to the problem. So problem one says, that's not it. Let me erase this. That was the other class. Segment AB measures 3 centimeters. Point A is the center of dilation. How long is the image of AB after dilation with a scale factor of 1/5? So let's call this AB. There's a line segment. This measures AB, right? And this measures 3 centimeters. And here's the center of dilation O. Right, so if we dilate that by 1/5, obviously it's going to get smaller. It's going to be like over here somewhere. Right, how long is the image after a dilation of 1/5? Well, take 3, multiply by 1/5, and it's going to be 3/5. So this is going to be 3/5. So that measures 3/5. How long is the image of AB after dilation with a scale factor of S? Well, it's going to be 3 times whatever S is, right? And that's your answer, right? We don't know what S is, so we use the variable S and S. So the scale factor AB is going to be whatever we multiply, whatever 3 multiplies by, okay? Whatever the scale factor is. All right, let's go to 3. Here are points A and B. F is the image of point B using A. Okay, so as a center of dilation. So all that. So you have to understand that this is the center of dilation. This is the center. Okay. And here's the distance. So remember, we used the example Daniel, Dylan. So here's Daniel, and I asked Dylan to stand right here. And point F, right? Where do I point F? If point F is going to be 1/3 of that distance. So point F is going to be somewhere around here, which is 1/3. But I'm going to be a little bit more precise. Okay, but it's going to be on that line, right? So let me just create this. So here is Daniel, Dylan stand creates this distance right here, right? And then I ask Sarah. I asked Sarah today to stand 1/3 of the way, right? And Sarah's going to be standing about there. That would be Sarah, 1/3. Well, let's do this the right way. So let's measure how long it takes to go, how not long, what distance it takes if you were in A and to walk to B. So if you were in A and you had to walk to B, think about this. You would go 1, 2, 3. So let me write this down. You would go 3 to the right. And then you would go 1, 2, 3. You would go 3 down. Okay, that's how you get from A to B. Now, I want to cut that distance, right? So the scale factor is 1/3. So all we have to do is take that and multiply that by 1/3. If I multiply 3 times 1/3, I get 1. If I multiply that 3 again times 1/3, I get 1. So when I ask Sarah to go 1/3, she's going to go 1 that way and 1 that way. So where's Sarah's going to stand? She's going to stand right here. So that, well, in this question, that would be point F. Right? Triangle ABC was transformed to triangle DFE. So this triangle became this triangle. So it got bigger, right? So it got enlarged, right? Dilation. So the scale factor, what do we know about the scale factor, is going to be greater than 1, right? Label the center P. Label the center of dilation P. Where's the center of that? Then determine the scale factor. Well, here. Is this the center of dilation? Is that what they're saying? Or this is the center of dilation? I think the center of dilation is here. So they asked to label, so let's put a dot right here. That's the center of dilation. So everything is going to be based on that. So sorry, I don't want to erase that. I'm going to erase this. So let's take point B. Let's compare B and F. Actually, I right? We want to find the scale factor. We know it got bigger, right? So you can obviously tell because it got triangle ABC, the shaded triangle, became triangle DEF. And it got enlarged, and we have to find what the scale factor is. Well, pick a point, and let's just focus on one point. And I'm going to focus on this, right, point B, and then I'm going to focus on point F, the same triangle, the same point, the same vertex of the triangle, except on the larger version. So let's start. So if I had to ask you to measure the distance from P to B, right? If we were to go from P to B, it would be that way, 3 units. Now, when the triangle got enlarged, right, let's measure the distance from P to the new point F. So it's 1, 2, 3, 4, 5, 6. It got to F. So how did the 3 become 6? It was times 2. So what was the scale factor here? The scale factor is 2. I'm going to take another point just to make sure that we're doing this correctly. And let's take point C. Let's take the point C, and then we're going to do point E, right? And make sure that it is a scale factor of 2. Point C. If you were P, right, and you had to walk to C, you would go, oops, you would go 3, oh my god, you would go 3 that way, right? 1, 2, 3, and then you would go 3 down. 1, 2, 3. What are you okay with that? That's from P to C. Let's now go P to E, right? So if I were to go from P to E, we go 1, 2, 3, 4, 5, 6. So we go 6 units that way. And then 1, 2, 3, 4, 5, 6. And 6 units this way. Look at 3. How did it become 6? Times 2. What about this 3? How did it become 6? Times 2. So what was the scale factor? 2. Kind of easy, right? Here's the draw the image PQRS after each dilation. A dilation using point R as a center of dilation and a scale factor of 2. Okay, so let's do 5 first. 5. We want to use a scale factor of 2. So let's take point Q. And first of all, how do I go from O to Q? From O to Q, I would go 2 to the left, right? I'll go 2 left, you can say 1, 2, and then I would go 2 up, 1, 2. So if they're asking us to use a scale factor of 2, that means I'm going to take those two numbers, multiply by 2, and that distance is going to go to grow to 4. Meaning, the new point Q prime, to get to Q prime, we're going to walk 1, 2, 3, 4 to the left, and then 1, 2, 3, 4 up. And that, ladies and gentlemen, is Q prime after a dilation of scale factor 2. And we're going to repeat the process with all the points. So point P, O to P. So if you were O and you had to walk to P, you would go 1, 2, 2 to the left, and then 1, 2, 3, 4, 4 down. With a scale factor of 2, what's going to happen to these two numbers? Well, times 2, times 2. Now it's 4 and 8. So going to point P prime, right? We're going to go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And there's our point P prime. So notice that the original distance gets double, right? So originally you had to walk 2 to the left and 4 down. Now you're going to go 4 left and 8 down. So that's P prime. So S is going to repeat the same thing. So let's just do S. If you think about it, how do I get from O to S? You're going to go 2 to the right and then 1, 2, 3, 4 and 4 down. Scale factor of 2, that means those two distances gets double. So to the right, 2 times 2, I'm going to go 4. And then down, 4 times 2, I'm going to go 8. So it's going to be 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8. And this is point S prime. Point R prime is going to be here. How do I know this? Is because it has to retain the same shape. So if I actually connected the dots, guys, right, it's the same shape. Okay, so distances, right, and if you count, let's call this the distance between Q and R. It's 1, 2, 3, 4 units. The distance between Q prime and R prime, guess what? It's going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? And so forth. And likewise, from Q to P, it's 1, 2, 3, 4, 5, 6. So Q prime to P prime should be 12. Right? 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12. Okay? The area does not get doubled. That's a completely different story. All right? But the dimensions and the distance get doubled. Okay? Why does this all look familiar? Did we do this in class? Maybe. Again, so 6, completely different problem, but the scale factor is a half. What does that mean? Everything is going to be cut in half. All the distance is going to be cut in half. So let's do Q here. So from O to Q, it's 2 up, and 2 to the left and 2 up. So instead of going 2 and 2, we're going to go 1 and 1. So here's Q prime. Same thing for P. We go 2 left and 4 down, so it's going to be 1 left and 2 down. There's P prime. This one, R, is 2 left and 2 up, but no, it's going to be 1 right. 2 right and 2 up, so it's 1 right and 1 up. So that's R prime, and obviously S prime has to be right there. That's with a dilation of a half. Okay. Here's triangle ABC. Dilate each vertex of triangle ABC using point P as okay. So this is our center. So everything's going to be based on that. Draw the images and label the. So they labeled A prime, B prime. So we gotta find out where it is. So guys, everything depends on the center of dilation. So you gotta identify the center is here. So everything's gonna be measured from here. Okay. So scale factor of 2. Let's go to A first of all. To go to A from P, it's 1, 2, 3. So I gotta go 3 that way. Because we're using a scale factor of 2, multiply 3 times 2. So now going that way, I'm going to walk 6 units. So here's P. 1, 2, 3, 4, 5, 6. So there is A prime. To go to B, right, I'm going to go 1 to the left, 1 that way, and then 2 up. And then 2 up. Sorry, not that way. 1 that way, and then 2 up. Right, that's how I get to B from the center of dilation. So scale factor 2, we're going to double those numbers. So instead of going left 1, we're going to go 2 left. Instead of going 2 up, we're going to go 4 up. So 1 left and 4 up. 2 left and 4 up. 1, 2, 1, 2, 3, 4. And there is our point B prime. For C, to get to C, I'm going to go 2 left and 2 down. So I'm going to go 2 left and 2 down. Scale factor of 2, multiply that by 2. So times 2 equals 4, times 2 equals 4. So now from point P, I'm going to go 4 left. 1, 2, 3, 4, and then 1, 2, 3, 4, which is, 1, 2, 3, 4, 1, 2, 3, 4, right here. So if you connect the dots now, you can see that it's the same shape, right? So your side measurements all got doubled, okay? The angles are the same. The area is not, obviously. Yeah, that's about it. What? If the length side of AB is 4.5 units, let me go back here. All right, so I think they're talking about the same. So if the length of AB, where is AB? AB, the little AB, is 4.5, and the length of side BC is 4.1. What are the sides of length? Well, it got double, so that's 4.5. This is times 2, so that would be 9. times 2 equals 9. 4.1 times 2 equals 8.2. Yeah. All right. Pretty sure we did this in class. Well, let me go back to this. No. So what if point P was in a different location? How would the size and location of the image change at point P? Well, why don't we do that? Or why don't I do it? So let me pretend that's not there anymore. And let's say this. I'm going to take these guys out, and these guys out, and these guys out. And let's say I said, hey, point P, the center of our dilation is right here. Okay? Actually, let me make it somewhere where it's here. Here. Right, point P, our center dilation is right there. And we want to see where the triangle. So the original triangle, remember, dilation of 2, where P was right here in the middle, that was a triangle. Let's see what happens when I change the center of dilation. So if this is a center dilation, let's go to point A. To go to point A, I will go 2 up and 2 right. Yeah? What was a scale factor of 2 means I'm going to go 4 up, 1, 2, 3, 4, and 1, 2, 3, 4, 4 right. Here is A. B. With B, I go, let me count, 2 left and 1, 2, 3, 4. So it's going to be 4 left, 1, 2, 3, 4, and then 8 up. 1, 2, 3, 4, 5, 6, 7. Shoot. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, and then 8 up, which is B prime right here. And then to C, I go 1, 2, 3. We're gonna double that. 4, 5, 6. And look where the triangle is now after dilation of scale factor of 2. Well, did it move? It moved because my center of dilation is completely in a different place, right? Would the size and location of the image change? The size wouldn't change, but the location would. Okay. Is that it? No, there's one more. Okay. Spiral. So this is, well, it's not. Ooh, I almost got caught. I was going to say that that's 2 parallel lines cut by a transversal. Is that a true statement? So this, right, it's parallel, cut by a transversal. So what does that tell you? It tells you that these 4 angles right here and these 4 angles right here are exactly the same. Right, right, the top left-hand side with the top left-hand side, etc., etc. So we have a special situation here, but not in this case. Why? Because this line and the other one should have been straight, but it's not. You can see that the other one's like this. So definitely not parallel. All right, and if it's parallel cut by this line over here, it does not create this special relationship between those 4 angles and those 4 angles. Those 4 angles and this group of 4 angles are not the same at all. Well, nevertheless, we can start filling. That's 35 degrees, so let's take them separately. So let me put this here, and let's call this 35 degrees. We learned that when 2 lines intersect, they create vertical angles. If that's 35, ladies and gentlemen, this is 35. So let me put that 35 there. How do I find this guy and this guy? Well, you know that these 2 guys here, oops, wrong color. These 2 guys right here are supplementary, right? Or if you want to look at these 2 guys, supplementary. Or these 2 guys, supplementary. So it doesn't matter which pair you pick, you know they're supplementary, which means this guy right here plus 35 has to equal 180. So if I subtract 180 from 35, I get 145. Well, and if you add that up, you get 180. So now that I know that this is 145, guess who's 145? This other guy is 145. The other example, let me do it over here. It looks like this now, sort of like this. So if this is 27, you know that this is 27 as well. just like the previous example, you can figure out this angle because 27 and that angle represented by the yellow color, they're supplementary, so they add up to 180. So all you have to do is go 180. Oh my god, maybe color you can see 180. 180 minus 27. That's 3, 7, and 2 is 5, 153. So this, the supplementary angle, is 153. So if that's 153, vertical angles are opposite, which means this fellow over here is 153. So we can go back here and make 153 and 153 there. Okay, that's it.